Hi there, and welcome to the 6th video from the Trigonometry Review Appendix from Stevens' Matrices, Vectors, and 3D Math, a game programming approach with MATLAB. In this appendix, we've covered quite a few subtopics from trigonometry. We had triangle trig, unit circle trig, consider them periodic functions. We transformed these around, made some ellipses and circles, but we sort of stopped talking about the tangent function right there by the second part of this. So here, our final video, part 6, we're gonna discuss the tangent function. So I'm going to go to that page and open it up into full screen mode. Okay, so I'm going to start discussing this in terms of tangent as a periodic function of a continuous variable, right, x, or t. T was what we were calling it earlier. And it's worth pointing out that it is just the sine of x over the cosine. So it's actually the ratio of two other functions. But I want to show you that that is not just an arbitrary definition. If we go all the way back to our triangle trig, right, and we have our angle here. So we have our right triangle with theta being in the corner here. We call this the adjacent side. This was the opposite side, and this is the hypotenuse. We basically had, I'll start with sine, that the sine of theta was the opposite over the hypotenuse. And then the cosine of theta was equal to the adjacent over the hypotenuse. Then we said, all right, the tan of theta is defined by the opposite over the adjacent. What's worth pointing out, and the whole reason I'm traveling back in time here to our triangle trig, is that if you just take the sine of theta and divide it by the cosine of theta, the h's cancel, and what you get is tangent theta is just sine theta over cosine theta. Right, so it's not an arbitrary definition. It really goes all the way back to triangle trig when we defined tangent. Right? But in terms of a periodic function, it's easier to think of it as the ratio of sine and cosine. So specifically, if we look at this ratio, our dashed curve is cosine x. So that's this one right here, cos x. The dotted, which isn't totally obvious to be dotted, is sine x. So I'm going to try to look at the ratio and see what happens. So it's going to be sine x, so it's the dotted over the dash. So right here, the dotted is 0 over 1. So my tangent curve, which is this thick solid line, is just 0. Right? But then if you start looking over here at pi over 2, notice cosine of x is 0. So I'm getting a 0 in the denominator, and that's bad, right? And so that's why we have this asymptote here, right? The function's undefined there because cosine is 0 at that point. And the same can be said at negative pi over 2. Cosine is 0 again. So the function tangent, the tangent function, is not defined at pi over 2, negative pi over 2, or 3 pi over 2, or negative 3 pi over 2. But within those domains, it does repeat itself. So it is a periodic function. It has a period of pi instead of 2 pi like the other two functions. And it is undefined at all of these points on the x-axis or the t-axis, right? And basically, this is just a way of generating pi over 2, 3 pi over 2, 5 pi over 2. It's just a bunch of odd numbers over 2. And you get positives or negatives, right? So it's all those vertical asymptotes, right? And it has a period of pi. And we actually don't use the tangent function that much. It's not a curve that shows up that often. However, we do use the arctangent function regularly. And the arctangent function is very useful for obtaining angles, right? It is also known as the tan inverse. On some graphing calculators, it'll be denoted tan with the -1 up there. I don't really like that particular symbol for arctan, but it is the inverse of the tangent function. The problem is some people tend to say that's 1 over tan, and then that doesn't make any sense, right? So it's the arctangent function. And what that means, so it's useful for this. Suppose I know where a point is in the xy in the Cartesian plane, right? And I want to know what is this angle, theta. Well, if I just draw this triangle, right, then this value here is x. This value there is y. I don't necessarily know the hypotenuse. I can calculate it. But what I do know is that the tan of theta equals y over x, right? So if I just use the inverse, I can get theta. So theta, well, I already have it written down. Theta is the arctan, or the tan inverse of y over x. But now the problem is that this arctan function will always return something between negative pi over 2 and pi over 2. Right? So it'll only return angles between negative pi over 2 and pi over 2. So in either the first or the fourth quadrant, right? And so the problem arises when you have a point over here. Right, suppose that's x and y. You'll take the ratio, you'll get a negative number, right, because x is negative, y is positive, but it'll give you an angle down here. All right, it'll give you this angle instead. So it won't really give you the proper angle. And there's some identities and some transformations you can do, and if you take a pre-calculus or a calculus course, you'll get into that. But we will be using software, and the thing to do then, if you have software, is to use this function arctan, atan or arctan, with two variables. Right? It may not always be called atan2. In MATLAB, it's called atan2. But these things are in your graphing calculators and in basically all mathematical software. And what it allows you to do is, instead of putting in the ratio, a single number, you get to put in the value of y, the value of x, and it will return an angle, right? And the nice thing about that is that if this is your point, it will return this angle, right? And so the atan2, or whatever your software uses, is great. But again, it has to be defined on some domain. And so in most cases, that domain is negative pi over 2, or sorry, negative pi to positive pi. Right? So for example, if your point xy is down here in the third quadrant, it will return, the atan2 function will return a negative angle. Right? But you can add 2 pi to that and get the positive angle if that's what you want. But it'll always hit it. You don't have to worry about the issue of doing your own transformations when the value of x is less than or equal to 0. Okay, so I recommend, and in MATLAB, what we use in this book, atan2 is the name of that. And also remember, if you're using atan, you might be tempted to put x first because it comes before y in the alphabet. But you always want to put y first. In other words, you want to put the numerator first, followed by the denominator, which in this case is y over x. All right, so this we use a lot because a lot of times we'll have a point and we want to find this angle. Right? If you want to switch to, say, polar coordinates or something like that. Okay, so that's the arctangent, and that's the inverse of the tangent function. And of the two, the arctangent is actually it will be used more often in this course than the tangent function. All right, so that wraps up our Trigonometry Review, which is Appendix A in the textbook. And we're done. Bye.